Hello everyone, welcome to our class. We are now in week 2, lesson 2. Balanced force and unbalanced forces. In our past lesson, we discussed the 3 laws of motion. Can you identify the videos which laws of motion is represented? Correct. That is the law of inertia. How about the other one? Great! That is the law of acceleration. How about the last video? Amazing! That is the law of interaction or law of action-reaction. Let us now state one by one for us to recall the concepts. Law of inertia. A body at rest remains at rest, or if in motion, remains in motion at constant velocity unless acted on by a net external force. Law of acceleration. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Law of interaction. For every action, there is always an equal but opposite reaction. Our enabling competency for today's lesson, we are going to demonstrate how body responds to changes in motion. Our most learning competency, infer that when a body exerts a force on another, an equal amount of force is exerted back on it. Our lesson objectives. Number 1, identify the forces acting on an object at rest. Number 2, examine the condition when 2 forces are balanced. Number 3, explain the effect of unbalanced force on the state of motion of an object. And number 4, determine the net force that acts on an object. You've learned that all objects fall because gravity pulls on them towards the center of the earth. Examine the picture showing the pen and the flower vase. What makes the pen and the flower vase stay at rest? The pen stays in place because there is another force that acts on it. The pen stays in place because there is another force that acts on it. This is supplied by the string, which is referred in physics as tension force. Tension force is the force which is transmitted through a string, rope, or wire when it is pulled tight by forces acting at each end. The vase, on the other hand, stays at rest because of the upward push exerted on it by the table, which referred to as normal force. Both tension force and normal force counteract the pull of gravity that acts on the objects, which makes them stay at rest. In both cases, you can now infer that the objects to remain at rest because the forces acting on the pen and the vase they have equal in magnitude. Equal forces but opposite direction. They are in the same line of action. The forces are said to be balanced. What is balance force? Forces that are equal in magnitude and opposite direction, so there will be no motion in an object. Here are some samples where you can see balance forces. Mango fruit hanging on the branch. Tension force exerted by the stalks is equal to the force exerted by the gravity. Thus, no motion is produced. Plate on the table. The upward force exerted by the table, known as the normal force, is balanced with the force of gravity. Therefore, the plate is at rest. Do you understand what are balance forces? Now let us proceed to unbalanced forces. If you cut the string connected to the pen will fall. The pen falls down because there is no more force acting on it to counteract the pull of gravity. In other words, the forces acting on the object is no longer balanced. If an object initially at rest is under an unbalanced force, it moves in the direction of unbalanced force. Now let us discuss the combining force. When we combine or add forces to determine the net or unbalanced force, let us recall the algebraic signs of positive and negative. To indicate the direction of the forces, unlike signs are used for forces acting on opposite direction. Like in the case of book lying on the table, the force of gravity and normal force are assigned opposite signs. Normal force is given a positive sign, while gravitational force is given a negative sign. If both gravitational force and normal force are given 3 units, then the net force along this line is net force is equal to normal force plus gravitational force. 3 units plus negative 3 units is equal to 0. And that is balance. If the sum of the forces equal to 0, they are considered balanced. The algebraic sum is not equal to the 0. The forces are not balanced. The non-zero sum is the net on the unbalanced force. This unbalance or net force would cause into state of motion. Let us go back again in the vase at the top of the table. The vase stays at rest because it has a normal force of 5 units and gravitational force of 5 units as well. Using the Greza method, let us find out what will be the net force of the vase. Given numbers, normal force is equal to 5 units. Gravitational force is equal to negative 5 units. Required net force. Equation. Net force is equal to normal force plus gravitational force. Solution. Net force is equal to 5 units plus negative 5 units. The answer is 0. Therefore, there is no motion produced or the object is at rest. How about if the object is already in motion? How will the unbalanced force affect its motion? Place a ball on the desk, then push it gently on the other side. Observe the motion of the ball as it rolls down on the desk. What makes the ball stop rolling after some time? Again, you need to identify the forces acting on the ball. You see in this figure that the force of gravity and normal force again acting on the ball. These forces are balanced, and so the ball stays on the top of the table. However, there is another force that acts on the ball along the horizontal line or along the force that sets the ball in motion. Do you still remember your lesson in friction in lower grades? You've learned that friction is a force that acts between surfaces that are in contact with another. Friction in general acts opposite to the direction of motion. In the case of the rolling ball, the frictional force acts between the surface of the ball and the desk and slows down the motion of the ball. Since you did not push the ball continuously, there is no forces present to balance the force of friction. So, the ball slows down and eventually stops. Again, due to the unbalanced force, the object changes its state of motion. Hence, we say that it accelerates. Note that acceleration is not just increase in velocity, but also a decrease in velocity. Thank you for listening.